So we're going to make a critical value table, a table to test for the absolute minimum. In the table, I have to put my critical value of 6 in the endpoints 0 and 8. And now our goal is to figure out what the actual function value is at each of these x values. We're going to use one of the points given to us. They said that f of 8 is 4, so automatically I know that that's 4. Now, to figure out these other ones, we have to use we got to think a little bit. It's a little bit of the fundamental theorem of calculus, but I can figure out the function value at 6 because we know the value at 8, and we know that the area of the curve, under the curve of f prime, is 7. So the way we can figure out 6 is we know that the integral from 6 to 8 of f prime of x dx, we know that that's equal to 7. And based on the fundamental theorem of calculus, the integral from 6 to 8 of f prime of x is f of 8 minus f of 6. But I know f of 8 is 4, and that will help me figure out what f of 6 is. So now I just have an equation to solve. So I'll subtract the 4, and I'll get negative 3 is equal to positive 3 is equal to negative f of 6, or f of 6 equals negative 3. So I subtract 4, I get a positive 3 here equals negative f of 6. And then because that's negative, I divide by a negative, I get a negative 3. So the function value at 6 is negative 3. We can do something similar to find the function value at 0. And I can do the integral from 0 to 8 of f prime of x. That's got to be equal to f of 8 minus f of 0. Now I can figure out the integral from 0 to 8 of f prime of x by adding up all of these areas. But when I do that, I need to remember that the 2, 6, and 7 are positive, but the 3 here is actually got to be considered a negative. So we'll add these up. 2 plus 6 is 8, minus 3 is 5, plus 7 gives me a 12. I know f of 8 is 4, and then I have minus f of 0, and I can solve for f of 0. I'll subtract 4, and I'll get 8 equals negative f of 0, or f of 0 equals negative 8. So now that I have my table completed, I'm looking for an absolute minimum. I'm looking for the smallest y value. So our answer for part B, we would say that the absolute minimum of f of x is negative 8. That problem is worth a total of 3 points. You get a point for making sure that you include 0 and 6 in the table. You get a point for having the negative 8, actually identifying that. And the table with the work, like all of the table, all of this stuff and all of this stuff here, that's going to be your last point, the work involved in filling in that table. Question C. It says, on what open intervals contained in 0 and 8 is the graph of f both concave down and increasing? Explain your reasoning. Okay, so if f is concave down, that means that f double prime of x is less than 0, or we could say that the same way that we can say f double prime of x is less than 0, we can say that f prime of x is decreasing. Okay, these both indicate concave down. Since we have an f prime of x graph, I'm going to focus in on where f prime of x is decreasing. We also want to know where f is increasing. And f is increasing when f prime of x is greater than 0. So we have two conditions on f prime of x for concave down and increasing. So we're going to look for the intervals where both of these are true, where f prime of x is decreasing and greater than 0. So we've got really this interval here. We're decreasing, but we're above the x-axis. We go from here to here, decreasing above the x-axis. We don't include this area down here because that is negative. And then that's the last interval. So our answer would be that x is between 0 and 1, and that x is between 3 and 4. And our rationale would be because f prime of x is both decreasing and positive. This is a 2-point question, and you're going to get a point for having the intervals correct, and then a point for your rationale. So we've had 1 point for part A, 3 for part B, 2 points for part C. Time to move on to question D. This is going to be a 3-point question, very different than the other ones. It says the function g is defined by g of x equals f of x cubed. If f of 3 equals negative 5/2, find the slope of the line tangent to the graph of g at x equals 3. If we are finding the slope of the line tangent to the graph at x equals 3, that means we want to find the derivative of g, so g prime of x, at x equals 3. So we need to actually find g prime of x, and then we're going to plug 3 into it to get our final answer. So to do the derivative of this, again, it doesn't seem like any part of the rest of the question matters for this. It's very different. So we get f of x cubed. The goal would be that you would see that this is a composite function where we need the chain rule. But the chain rule, our answer is still going to be in terms of f of x. So we're going to get 3 times f of x squared, that's the derivative of the outside with respect to the inner, times the derivative of the inside, which would be f prime of x. That is our derivative. Now, the rubric gives just finding that derivative 2 points. In the next part, we're going to plug in 3. So now I'm going to plug in 3 wherever I see the x. So we got 3 times f of 3 squared times f prime of 3. Now they gave us f of 3 for a reason, because we were going to need it. So f of 3 is equal to negative 5/2. So I've got 3 times negative 5/2 squared times f prime of 3. And f prime of 3 I can find on the graph of f prime. F prime of 3 is equal to 4. That's our point right there. So I'll do times 4. We could leave it like that if we wanted, but I think we can figure it out. We've got 3 times 25 over 4 times 4. Those 4's would cancel out, and we'd have an answer of 75. And that would be the final point for this problem.